मेरे पापा का भी तबीयत खराब।
Hello, hello. Is my voice audible to you all? Hello. Okay, nice. Let's just wait for 1 2 minutes. Right at 7 3 we will start the session. Hope you all have practiced the yesterday's questions. Okay. Okay. So is there any doubt in the yesterday's session? Then you can just ask me in the comment section if you have any doubt related to the yesterday's concept or today's questions that we will be performing. These are the most like the important ones that are asked in like any interviews, and also very easy one, though they may be medium to hard questions on lead code and all of those stuff, but they are really very easy questions. So I think we uh, we can start the session. Okay, let me just share the screen with you all. Okay. Okay. So let's start the session. So we will look at what all things we will be looking at in today's class, like LIS, longest common subsequence, longest increasing subsequence, knapsack, right? Unbounded knapsack. They are very easy questions once you understand the basic logic. Okay, so I'll be asking 1 2 3 questions also. So like if you get the point, then just say yes or no in the class. Okay, just answer in the comment section. Okay, so I think let's go to this. So today, what we will look at that we will be covering the 2D DP. Actually, 2D DP is nothing like in 1D DP. What we did, we memoized in a 1D array, right? We took a 1D array and we stored our answer. But now we will see that there are two things that will be changing in our code. As two things will be changing, so we require a 2D DP. 2D DP to memorize it, right? Definitely, you need 2D DP to memorize it. So that's the case. Okay, so that's why these are 2D DP. We will look at that why the longest increasing subsequence, longest common subsequence, knapsack 01 means that either you take the full object or you skip the full object. So that's what the knapsack is. Okay. Then we will look at the shortest common subsequence and the knapsack unbounded. Okay, so this is what that we'll be covering today. Okay, so this is what that we'll be covering today. Nice. Okay. So now we can see that in longest increasing subsequence, you can just open the GFG question. Now let me just read out the question that what is longest increasing subsequence, and then we will form a good story and we will write it in our code. Okay. So like the main motive is that you may understand that how to form that recursive relation, because once you form that recursive relation, I think most of the things are sorted for you, right? You can actually memorize it in a very simple way. Okay, memorization is a very simple process that you can perform. Okay, So let's start that what this longest increasing subsequence means. Suppose there is an array 5, 8, 3, 7, 9, 1. Okay, so this is the array. So the subsequence is that you can skip the elements from the array from between, like it should not be continuous. So that's the meaning of subsequence. And we can see that 5, 7, 9 is the longest increasing subsequence, like 5, after that 7, after that 9. So so this particular questions actually give us the intuition that at a particular point of time we will be having two options, either to include this particular answer in our question or either to exclude this particular answer in our questions. And these two options, after considering these two options, we have to return the maximum. So I think we have actually made a story up that what we have to do is that we have to either take it or either skip the particular, say what you say, the particular element. So this is what we are going to do here. Let me just write it. Write it here so it's more easy for you. Suppose this is for today's session. Okay, so 583791. So it is 5. Let me just write text. Okay, it says 583 and 791. 791. So the answer, you know that it is already stating that it is 579 is the longest increasing subsequence, and that is also visible through eyes. So I don't think so there is any like problem in this, in identifying that what is the longest subsequence in this. So considering this particular part, we will be starting from this particular 5. Okay, so the story is very much simple, that we can either include 5 in our answer or we can exclude it. Okay, because I am saying why exclude it, because if we exclude it, there might be a possibility that there is a another long subsequence forming if we not include this. So you have two options, that either to include 5 in your answers, that I'll say I by include by I, or you can exclude this. So these are the two paths that are actually forming for you. Okay, and what it is saying, that it is asking for the longest subsequence, means it is asking for the maximum answer. So means if you get suppose here something you get as answer 1 and here you get an answer 2. So what you have to return from here, you have to return maximum of these both. You have to take max and you have to return the max of all these two possible solutions. Okay, if anyone has attended yesterday's lecture, they must have been easily identified this, that why we are doing this. Okay, so this is the whole story. Okay, if you get the recursive solution in a very simple manner, base case is nothing. Okay, I'll tell you what's the base case. Base case is simple. If I reaches here, suppose this is n minus 1 here, because it is a zero based indexing. So if I reaches here, like after n minus 1, okay, so there is nothing present in the array to include or exclude. So the base case is simple. When I will become equals to n, when I becomes equals to n, we will directly return 0. Okay, because there is nothing to include or exclude. So answer is very much simple, that we'll return 0. We will return 0. Any doubt in this particular point? Okay, it means what can happen, that there are two possibility, that if we include 5, hope like there would be a possibility that including 5 will lead to a, what you say, a bigger answer or a longer subsequence, or there can be a possible solution that not including a, we can find a solution. Like suppose I'll give you a good example also. There might be some of examples here. Okay, it is starting from 10. Just suppose, think of an example. Let me just write it here. Right, suppose instead of 5 4 5, there must be kind of Just don't think that this is the array. Just think that there is an array which states that uh, let me just include it here. So 10, 9, 8, 11, 12, 13, and 14. So the longest increasing subsequence that you can get is either by 9, 11, 12, 13, and 14, which is 5, or you can say 8, 10, 11, 12, 13, and 14. So this is what the possibility is, that whether included it we can get the same. So that would return the same answer. But there are two possibilities, that we can either include this or we can exclude this. Okay. As this particular as this particular situation arises, when you don't know that there might be some solution by including it or maybe excluding it, we use DP, or you can say we use recursion. Okay, because many of the people have this doubt that where to use recursion. So that's why I told you in the beginning that this is also a very, like, if you are starting recursion, this is very easy manner in which you can understand and answer these questions. So tell me that if you are having any doubt in the longest increasing subsequence explanation, because then we will start coding. Okay. If there is no doubt, you can just say no so that I will move ahead. Okay. Okay. Okay, nice. So what we can do, we can come here and we can start what we have just, like what I have just told you, that we have int sol. Okay, int sol, int prev, int I, vector in, and of arr, int n would be passed. Okay, we will pass the dp array later. Okay, so in what conditions you can actually take this particular take this particular index, uh, suppose 8. If you are taking 8, then what can be the condition? The condition is simple, that the previous element should be less than it. Okay, so this is what we are going to apply here, that either prev is not selected, either there is no previous, or if there is a previous, then that previous value should be less than the current, that only then we can include it. So we can write, if prev is equals to 1, not equal, is double equals to 1, and ARR of I, the current index is greater than ARR of prev. Okay, if this is the case, then what we can do, we can simply take it. Okay, then what we will do, we will call on a take, and we will say 1 plus solve of uh, the previous value will become now I, and we will move to I plus 1, then we will do ARR, and then n. Okay, so as two things are changing here, previous is also changing here with time, I is also changing here with the time. That's why what we are heading towards, let me just yeah, here. So what we are heading towards, we are heading towards a 2D DP array memoization, or I have a option that I can skip it. If I skip it, then what I'll call on, I'll not take 1 plus. We are not going to do 1 plus here, because as we are skipping it, right? So we will make prev remain as prev. We will do I plus 1, as we are skipping. We will do ARR and n. And in return, what we have to give, we have to give max of these both, take and skip. So this is the recursive relation that has been formed, and this is the correct recursive relation. Okay, now talking about the base case. Base case is simple, that if I reaches n, means it has surpassed all of the indexes of array, we are going to return 0 from it. Okay, and we have to declare a take here. Okay, because then it's kind of a global, because if I have declared in this braces, it would have remained local, and our answer would not be coming perfectly. Okay, so I think without memoization we can just run it for once, and after that what we'll do, we will run using memoization. Arr.size. So is this screen clear to you? Means may I zoom in or zoom out if you are like having a proper view of the screen? Is this is I think this would be good. Okay. Now what we will return? We will return solve of -1, because till now we will be passing prev as -1, and means not selected anything, index from 0, passing arr and n. Let's just try. I think for like base cases it should work, but it would give a TLE. Like let me see that what it is saying. Okay, I think that this particular thing is coming because we have not added till now the DPM memoization. But just don't look at this particular thing for now. Not and there should be or. Okay, now we will run. I think this would work. Okay, this is working perfectly fine. Okay, this is working perfectly fine. So what we did mistake, that there should be two conditions, or that either previous is not selected, and if previous is selected, then this particular index that we are selecting should be greater than the previous one. Okay, then what we call on the recursive, we call that we have taken this particular thing, we have added one plus, and what we call on the recursion is that the this particular index will now become previous, so we have passed I in it, we did I plus 1, and the recursive call will handle all of these things by their own self. Now you can see that there are two things are changing. So what we will do, we will make a 2D array, and we will store the result simultaneously. Okay, so memoization works perfectly. Vector of int n minus 1 n minus 1. We will pass dp here, command v, and okay. So we will simply pass that dp of, now as two things are changing, I and prev, so these will be the two parameters on which my dp array would be formed. So dp of I and prev. Okay. Okay. So like before heading towards adding of the DP array, tell me that is there any one condition that I have to also add to keep like see the edge cases, that we have to see that if prev is -1, we cannot actually, like what you say, we cannot actually access elements. Like let me tell you here, there is nothing such as this is a DP array. Suppose ARR is a DP array, there is nothing such like this. If this is 1 and this is -1, so for this, that if the prev is -1, we have to take cases. Okay, we have to make it as a case that if prev is equals to -1, then we will not store in our 2D DP array, because this would lead to undefined spaces, because there is nothing space such as 1 or -1. So we have to take care of that also. Okay, so we will look at here that if prev and prev dp of I and prev, as these two things are changing, is not equals to -1, then I am going to return dp of I. Okay, and we will be adding that if prev is not -1, if is not equals to -1, only then we will store it in our dp array. So what we are going to do, dp of I and prev will become max. Okay, we have to declare this escape above this. Okay, okay, because this would work perfectly fine, I think so. But only the thing that we have to change is that we have to pass dp here. Now let's see that is it running or not. Okay, it is running perfectly fine, and if you submit, all of the test cases would work. So what we have done here, okay, all of the test cases are working. So what we have done here, we have actually reduced our complexity. That you all know that recursion operates on order of 2n. So by memoization it, what we have done, we have reduced it to the here, like to a this complexity order n log n, and space is n, because we are using n spaces, right, in memoization. So this is the longest increasing subsequence. If anyone has any doubt, just ask me in the comment section, and then we will move towards the longest common subsequence. Okay. Okay, I think no doubt, very well. Like if you are understanding, that's very good thing. Because see, this is what actually happens, right? Yesterday, what was happening, around 100 or 200 students were there, right? But this is why, like, people scares from the, I think, what do you say, DSA, because they scare from the DSA because they don't practice it well. Okay, I also used to scare sometimes, right? Many times, right? I have like started from the array beginning, but I think you should not be scared of DSA, because it is an important part of your interview preparation. At the end, you have to touch the DSA, and if you touch this particular thing at the end, so then it would create a proper mess. Okay, that's perfectly fine. If you are not understanding things today, maybe tomorrow you will get, and maybe tomorrow you will get understand things in a better way. Okay, so let's move on to the longest common subsequence. So the longest common subsequence is a, like, I'm not reading this, I'm actually conveying it to you. Okay, you can also read it. So what it is saying, a b c d g h is in the string 1. A E D F H R is in a string 2. So the subsequence, you know that I have already told you, the subsequence means we can skip the part. So we have to look at the combination in these three, such that all of the characters matching to the S1 and vice versa, like S1 characters also matches to the S2, and we have to find the longest of it. Suppose the longest common subsequence is ADH in all of these things. So ADH, ADH. So the order is also maintained, and they are coming in both of the what you say, both of the strings. Similarly, here would be AC. Suppose ABC, and in this AC. So the AC is also here, but AC in string one is in like subsequence. Okay, so like we can eliminate B. So AC is one of the subsequence of S1. So this is the longest common subsequence of length 2, which is present in both of the questions. So so I think this would also be kind of a approach, that either we can include this in our answer, or we can include this in an answer. So I think you are already comfortable with this particular approach. Let me just tell you here. Suppose there is a question. Let me explain you the story first, and then we'll code it. Okay, then we will code it. So suppose there is a string 1 which is saying that a b c d e f. Okay, then it says here S2 is a b, not like this, a b l m n d e f. Okay, so at each point, what is going to happen, you are going to point here with an I. Okay, you are going to point here with a J. So definitely two options are forming, that we can include this A. Okay, there are possibility, you have to check for the possibility, and you have to like give it to the recursion to solve it. Just solve for one base case, and then let the recursion solve for the rest of the, what you say, rest of the problem recursion will handle. Okay, so there is a two option. that either you can include I plus 1 and keeping the j here, or what you can do j plus 1 and keeping the I here. So there are two options that you will have. And if a is equals to a, then what you have to return, you will return on 1 plus solve, and you will increment both I plus 1, I plus 1 here, I plus 1, and j plus 1. Okay, because you have found the common in both, so you will do I plus 1 and j plus 1. And after that you have two options, either to include from s1 or either to include from s2. So after that, what you will return, you will return maximum of all these two options. Like suppose you get here answer 1 and you get a answer 2 here, because it is asked for the longest common subsequence, then you will return the max of these all two options. Okay, and the base case are simple, that if I reaches here, then return 0, if j reaches here, then return 0. So these are the two base cases that I found, and I think now we can start the coding part. Okay, we'll go on and solve. Okay, and solve int I would be referring to the current index in this s1 string, int j would be referring to the current index of the s2 string, and we can just copy paste them here, passed by reference. Okay, end means passed by reference. I think this is clear to you. We will add the memoization later, but let's just solve for the base case. So the base case is simple, that this would be the base case, that if I reaches s1 dot length, or j reaches s2 dot length, then return 0. Okay, and I have already told you that if s of I, suppose here that we have seen is that if a is equals to a, then what we will do, we will say 1 plus solve of I plus 1 and j plus 1. Okay, if s of I is double equals to s of j, then what you are going to do, you are going to return 1 plus solve of I plus 1, j plus 1, s1, s2, and dp. Okay, then you have int option 1 and you have int option 2, that I have already discussed, that whether to include like I plus 1 and keeping the j at the same position, or whether to exclude it. Okay, solve of I, j plus 1, s1, s2. Okay, so s1, s2, and dp will pass later. And you have option 2, that you can either go for solve I plus 1 keeping the j at the same position, because there is a possibility that keeping this particular position same will return you a maximum answer. Return max of op1 and op2. Then you are going to return solve of 0. We will starting from 0, s1 and s2. Okay, so we'll just submit for now. Not we will run for our base case. What it is saying, okay, it should be s1 here and s2 here. Where we have used dp, okay, we have to remove this. We will add dp later. Okay, now answer is coming perfectly fine because it is coming 3. Okay, so any doubt till now in longest common subsequent, you can ask me, because we will add memoization now. But before adding memoization, any doubt, you can just say yes or no. Okay, nice. We can move ahead, or I think so, because as two things are changing here, we will require a 2D DP array. Okay. We will make a 2D DP array, vector of vector, int db of n. Let's just pass it here using reference. Okay, and we will do dp of ij. We will update dp of ij as this, and we will ask that if it is not 1, then return from here itself. Okay, let's just see that what has happened up here. It is saying that okay, we have to pass dp here. Okay, now answer is coming -1. Okay, here is it needs to be -1, not equals to -1. Okay, I think now we can submit it. Okay, it is working perfectly fine. Okay, so the this we have done. We have done longest increasing subsequence, longest common subsequence, and now we will move towards 0 1 knapsack. Okay, I think these are very popular questions. You must be knowing very well. Okay, so okay. So let me just ask any doubt till now. I don't think so because these are very easy ones. Okay, means I have actually made very easy for you. So even if you are not able to code, just understand how the recursive relations are formed. If you understand that how the recursive relations are formed, then it is easy for you to like go with it. Okay, now in 0 1 knapsack, you can solve it using take or skip approach. Only the thing you have to keep in mind that if you are taking that particular thing, I think if someone is not familiar with 0 1 knapsack, I'll tell you. Let me just tell you here that there are two arrays. This particular chore, or you can say this particular thief, has to select from the value and the weight. So this is the building. So this is the object. Suppose this is an object 1 which is having a weight of 4. This is an object 2 having a weight of 5. This is an object 3 which is no, this is an right. This is a object which is having a value of 3, or you can say they refers to the 3 coins, but it is having a weight of 6. So what you can do, that particular thing, either you can take this particular thing or you can skip this particular thing. You are skipping in hope that there must be an answer which is available in the further array. Okay, but you have to keep in mind that you are given a w capacity. You have a like a bag. In that bag has a particular threshold of like holding a weight. So if you are taking this particular one, so from weight you have to decrease 4. Okay, so now only two things will be changing. That you will be moving, that I the index will be moving, and weight will be changing with the time. So this is the 2D DP array. You got it. But did you get the point that once you see, let me just see. Okay. Mm, okay. So this is what is happening. So we have to keep in mind that when we will be taking this particular thing, we will be subtracting the weight out of it. Okay, so is this point clear to you? Just say yes or no. Is this particular point clear? Okay. Okay. Okay, nice. I think we can now move towards the like the explanation part, that what I was trying to say. Let me just open the chat in here so that I can constantly view your chats. Okay. So what I just mentioned, that there will be two things that will be changing with the time. That once you are selecting some object which is having like a value, so you will be increasing your answers because you need the maximum value or you need the maximum points. But okay. So but with the time what will be happening is that you will be also like decreasing the capacity, using the capacity of the bag that you are holding. So two things will be changing, that value and weight will be changing with the time. Okay. So I think we can start the coding part now. Like before the coding, let me explain this is 01 knapsack, this is the unbounded knapsack. Okay, so there is a very little difference that I will ask you to answer. Okay, because it is a very easy one. So suppose here, let me just copy it. Come on, let me just see this. uh, Command C. Okay. So this is the question that you are having. So what I was talking about, that you have two options. Okay. Either to take this particular one value or either to skip it. Okay. So I will tell you that what happens when you like take this particular value. What you will do, you have two options. That what you will perform is that you will take the current value of I. Okay, you are including this particular thing in your answer because you are saying that, and you will say I will call on recursion, or I will call on recursion, and I will do I plus 1, means give an answer from the like the upcoming indexes. And what you can do, the particular weight which is 4 for now, then weight will become w minus weight of I, or you can say weight of 4, wt of I, because you have chosen this particular index. Okay. Or you have a option, or you have an option here, suppose coming up here, that you skip this particular part. So if you skip this particular part, you will call on solve. Okay, solve I plus 1. And as you have not chosen anything, so you will keep the weight same because you have not used any capacity. And what you will return, this particular thing you will answer, that what it is asked, it has asked the maximum value that someone can achieve. So what we will return from here, like this is an option 1, this is an option 2. So what we will return from these two, just answer in the comment section. So let me know that you are getting my point or not. Okay. What we will like what you will get, like what we have to return, just say like we have to return maximum or we have to return the minimum. Just say in the comment section that we need the maximum things to be taken in the minimum weight, right? So definitely you will return maximum of these two options. Okay. So you will return maximum of these two options. So the code will be very simple, that we'll go on int solve. Okay, this I will be referring to the current index that we will be watching at. We'll pass this all things using reference. Okay, directly copied. Okay, we will add dp later. Okay, we will add dp later, that we will see. So yes, talking about the base case, I think I'll so there will be two base cases that will be formed. What will happen, either if your weight is 0. Okay, if your weight is 0, if your capacity is 0 to take it, so what answer would you expect? You will return 0. Okay, definitely you will return 0, there is no doubt. If your bag's capacity to hold things is 0, then what will you take from here? you will definitely take nothing and you will return 0 from here. Okay. And are some okay, and what we will do, we will that if I has reached here, like it has surpassed all the index, there is nothing left for it. So what will happen? You will return 0, means there is no value that is left, left with you. So what you will do, if I has reached the nth index, means it has surpassed all of the n minus 1 index, you will return 0. So these are the two simple base cases. I think you must have analyzed it, okay, because these are very simple one. Okay, because these are very simple one. Let me just code it for now. Okay, so two cases, that if w becomes 0, like the weight capacity becomes 0, or I, or I, uh, not I, oh, I reaches val dot size, then what you have to return, you have to return 0 from here. Okay, you will return 0 from here. Okay, and if suppose we are taking this particular thing, that if weight of I is greater than w, that we are checking that if the current index value is having a greater weight, then what you will do, you will simply skip it, right? You will just going to simply skip it. You are going to return solve I plus 1 val, okay, I plus 1, let me just do one thing. Right. Definitely, if the particular index that we are at is having a greater weight than our capacity, then there is no options in which we can do. Right. We have to skip it. We have to skip it. Okay. Then val, then weight in it. Okay, and then you have two options, either to take it. Okay, either you take it val of I plus solve. Once you take it, what you do, I plus 1, then w, the and weight of this particular index that you have chosen for now. Okay, chosen for now, well, and weight. Then you go to end skip and you go for solve. Okay, solve, then I plus 1, weight will remain same because we have not chosen anything, then val, then weight. Okay, and what we have to return, we have to return max of all of the these two options. Okay, all of these two options. Okay, all of these two options, like the take or skip. Okay, now int n will remove to val dot size. I think we can add the dp simultaneously because you all must be very much comfortable with the adding of dp. Okay, because if I add dp now, then this particular question would be easy for you to understand. Int dp of size n, and each column would be having -1 in it. Okay, we'll return solve. Okay, we'll return solve starting from 0. W is provided in the question itself. We'll be providing it val, we'll be providing it wd, and we'll be providing it the dp array also. We'll just take it, we'll pass it by reference. Okay, we'll pass it here by reference and reference. Okay, once we pass it by reference, we have to pass it here also in the simultaneous recursions. Nice. Then what we can do from here, what we can do, we'll add that condition that if dp of I, as two things are changing, so dp of I and w would be formed, is not equals to -1, then return dp of I, dp of I and w. Okay, this is has to be passed, and I have to update dp of I and w here also. Okay, okay, nice. And what we have to pass here also, I think dp has to be passed here too. Okay, return dp of I and w, because we are skipping it. If definitely if someone's value or if someone's weight is more than our capacity, then we will skip it, right? Because we will be looking at that there would be a chance that a maximum sum can be formed after skipping this. So that's why we have added this statement, that our result should never get into the negative ones, because negative weights never exist. Okay, because negative weight never exists. I think we are good to go. Let me just check that we have returned our base case here. We have returned the dp. We have checked for if the weight would not get minus. Then we have options take it or skip it. We have if we have taken it, then we have reduced our capacity of that particular value. Okay, if we have skip it, then what we have done, we have keep the weight at same, but we have increased the value of our index in the simultaneous recursion call, and we are returning dp of iw here. I think it should run perfectly fine. Okay, okay, where it is saying it should be dp. Okay, and it should be wt here, weight of I. Okay, in the 12th line it is saying, okay, let me just see for once. Okay, expected. Okay, plus this should be this. We are not including this, right? Now our answer is looking very much perfect, and we can submit it, because now we have reduced our complexity to a very good numbers. So right, so all test cases are passed. Okay, now talking about we have talked about 01 knapsack. So why it was 01? Because what was happening, that we are either taking it or we are skipping it. There is no duplication of values. Okay, so now what this 01 knapsack is that you can duplicate the value, like there should be duplicate value, means you can take one n number of times. Okay, so the only difference between the code of this particular thing, or the what you can say, the logic. Okay, okay, once minute, sir, attendance cannot be marked if showing submission date. Okay, so now the updated attendance list has been updated. Okay, so you can just update, like mark your attendance. Okay, okay. So now the updated attendance list has been spent. So you can just do that. So now what I have told you, that what we were doing, we were taking it, and what we were doing, just move ahead, because there is, we cannot duplicate this particular, what you say, duplicate this particular index. But now what we will do, when we are taking it, we will not do I plus 1, because there can be possibility that taking this particular value again and again can lead us to a maximum solution. So just by changing this particular statement, what we are doing here, when we were selecting it, we were moving ahead. Okay, and then what we did is that, let me just, okay, the things are same here, knapsack. So I can just copy paste this particular code. Okay. Now, as duplicate items are allowed, so what we will do, when we are taking it, we will not do I plus 1. Okay. This particular will give a give the same answer. I think so. Okay. I think, okay. So here it is mentioned capacity, so we cannot actually copy paste the same code. But yes, we can write the code in the similar manner. Okay. So we will start writing the code. Is this particular logic clear, that what we are doing here? That in the 01 knapsack, you are not allowed to take the repeated items, but now you are allowed to take the repeated items. So what you will do, that when we will be clicking on the take, okay, when we will be clicking on the take, then I plus 1 would not be that we will be doing, because there can be a solution that if we take this particular thing again and again, this will lead to a optimized solution, or you can say not optimized, a maximum solution. Okay. Okay, so if this particular point is clear, you can just say yes. Okay, nice. So we can move towards the coding part, and then we will end the session. Okay, we will end the session. Uh, okay, we will end the session. Okay, so let me just see if this particular point would have been cleared. I think that question would be easy for you to solve. In similar manner, we will call on solve. Okay, we will call on int I. We will just take it from here. We will add v here. Okay, now the base cases are the similar, that if capacity is double equals to 0, or I is equals to val dot size, it has means surpassed all the indexes, then what you will do, you will return 0 from here. Return 0. Okay, we will add dp in like much in later part. Okay, so you have two options, either to take it or either to skip it, right? So what you can do, that you have only this option, that you will take int min. So the same code, that if the capacity, which is the current capacity, is minus the weight of the current index, is greater than equal to 0. If this coming to be 0, then what we can do, we can take it. Okay, we will take it, and what we will say, val of I plus solve I val weight, and we will subtract from the capacity, as we have taken this particular thing, weight of I. Okay, or we have the second option of int skip, which is solve of I plus 1 val weight and capacity, and we will return max. Okay, so I think just we will run it for okay, we will run it for the base cases. Okay, you will run it for base cases for now. Val weight capacity, I think this should work. Let me just see that I have added all the things in a perfect manner. Okay, so the things are working perfectly fine. I think I can leave the adding of 2D array upon you. Okay, so today's lecture has been ended. If any doubt, you can ask me in the comment section. Otherwise, you can leave the class. Okay, and do fill out the attendance form. Okay, that's the mandatory step. Okay, so we have actually added this particular step here. Okay, so these two solutions are very much similar. You can similarly do it here also. Suppose what you can do, I think you can make this particular thing here, that if w minus weight of I is greater than equal to 0, then you have intake here, which is int min. for now, because we will be returning maximum. So if it remains in, then we will return this. Okay. Command X, Command V. Okay. We will take it here. I think we can run it. Simply it will give the same answer. Okay. So it is returning the same answer. So both logics are fine. So I have explained you using all two logics. Okay. It is also working perfectly fine. Okay. Definitely, the certificates are benefitable, right? When you show that you have done a boot camp, it actually creates a good impact. Okay. So, if any other doubt, otherwise you can leave the session. Okay. And do fill out the attendance form, because I will end the session in 1 minute or 2 minutes more. Okay. So, I think we can end the session. Please do fill out the attendance form. Okay. I am ending the session. So you can just uh, fill out the attendance form. Okay. Thank you. Good night.